Any sufficiently advanced technology is indistinguishable from magic.
And we are here today, my friends, Jorge Cham, Daniel Whiteson, for their second book. Their second book is a phenomenal book. It is called Frequently Asked Questions About the Universe. And it's lovingly and tenderly illustrated by Daniel, I believe, right? Daniel, you're the illustrator for all these.
Yeah, but I farmed it all out to Jorge.
That's right.
Jorge has, as of course,
I'm an outsourcee.
Yeah, you're doing the job that Daniel doesn't want to do. You know, a big shot professor, right? You know, what are you going to do? So, guys, I followed your meteoric rise for many years. Your story and legend are well known. Actually, you were I think you were my first two kind of legitimate book guests for a book release. We did a podcast for Into the Impossible way back in 2018, and you guys were on for your first book, We Have No Idea. And then you came to San Diego, and we did a live event with you, Cliff Johnson of USC. I think Physics Girl was there as well as yours truly. And that was a wonderful event. And I want to thank you for returning, coming back on the show. And I've been on your show, and I do just have the utmost delight whenever a new episode of your podcast drops, Explain the Universe. But today we're going to talk about frequently asked questions, facts about the universe. First question, guys, your first book, We Have No Idea. Why should we trust you now?
Yeah, we should have set ourselves up for not having a sequel. Although everyone joked that our sequel should have been called We Have Some Ideas Now.
It's a great question, though, but you should trust us because we're the ones who will admit when we don't know. We're not just here to sell you on science. We're here to admit what we know and what we don't know, because for us, you know, the majesty of the unknown is what drives us, our curiosity, and drives all of scientific discovery. So that's what it's all about. And, you know, you notice that it's frequently asked questions about the universe. Not all of them contain definitive answers.
That's right. And I think actually the questions are almost more interesting. You know, people think of scientists, like the three of us, as people who have all the answers. But actually, I think it's more important, guys, maybe you guys agree or not, to have questions. What do you guys say to that? Is it more important? Are questions underrated? Because everyone can have a question. Like, those of us who have kids know the ultimate explanation is because I said so. But are questions really so important, or is that kind of a platitude we tell our readers and listeners?
No, I think questions are what science is. You know, science is just people asking questions. I think a lot of people out there think of science as this like monolithic institution that just sort of like churns out knowledge every year. But they forget that it's a bunch of people, and science only makes progress when some person has decided, I'm going to devote my life to this topic. I want to understand how butterflies migrate. It's important to me. Or I want to know how the universe began. Or I want to measure the anisotropy of the CMB, for example, because everybody has to make a choice. And so science moves forward because individual people ask questions that are important to them to know the answer to.
And Jorge, you're, of course, scientist, engineer by training, but you also approach things in a very visual way with your, very whimsical PhD comics series that I've been a fan of for decades, it feels like now. I want to ask you, do you answer or ever pose questions visually? Is that even a concept that makes sense?
Yeah, I ask questions all the time. You know, I have a notebook. It's digital now, but it's where I sort of outsource my brain and where I put all the questions I have, and then I have fun answering them. But yeah, no, I do think sort of visually, which is why sometimes a podcast is challenging to think about these things. But no, yeah, it's pretty interesting to sort of think about some of these abstract or like grand ideas about the universe in a sort of, and try to translate them into cartoon form. That's kind of the fun challenge for me in these projects.
I see the evolution, both of you guys individually, but also collectively as this Bourbaki-like set that you guys comprise. You guys have really evolved and branched out. We were joking before I hit record. You guys have this multimedia empire. You've got audio podcast dominating, always top 10 science podcast, Explain the Universe. You've got Eleanor Wonders Why, just a marvelous resource for parents and for anybody who's interested in kind of exploring big picture things, but also, this character, Eleanor. So actually, we didn't talk about that last time because I don't think she existed. Talk about the evolution, the origin of Eleanor, and then we'll get into this delightful new book. So whoever wants to start.
Yeah, I can chime in. Eleanor Wonders Why. It's a kids show that airs on PBS Kids. It's for preschool to sort of like first, second grade, and it's all about inspiring curiosity in kids. You know, we talked about how science is all about asking questions, and it's about inspiring the little scientists that every kid is born with. You know, every kid has all this curiosity about the world. They want to know how the world works, and so they have questions. And unfortunately, sometimes society beats that down eventually. And so we were trying to champion the other part of it, which is to encourage kids to be curious, to encourage them to ask questions, and also to kind of give them some tools they can use to answer their own questions. And so the origin of the show was actually kind of independent of our book and our podcast. We were sort of in the middle of doing those projects, but then I got an email from someone at PBS saying they were looking for new ideas. And so I wrote Daniel in, and we pitched the series, and we based it on our kids. So Eleanor is the name of my daughter, and we also based some characters on Daniel's kids. And so it's a big passion project. It's an amazing project just because it reaches so many kids, in not just in the U.S. but all over the world, and hopefully brings a little more curiosity into all of those households.
Mm-hmm. And Daniel, I've gotten in trouble lately because I've been kind of preening and saying things like scientists who get paid by the public, like you and me, we have a moral obligation to explain what we do to the public who pay our salaries. But I shouldn't speak for all scientists, should I? What is your take on the obligations of a professor? As I expect, when I wrote different books and did different projects, my department chair was like, "Oh, we won't punish you. We probably won't punish you." Of course, I had tenure by then, as you do, but do you feel an obligation to explain things, or is it just something that you're naturally talented at, and therefore you take to it? But if you didn't have that talent, maybe you wouldn't be doing it. Do you feel it's an obligation, and if so, how do you approach that balance in your career between teaching in a university, top university in the world, and doing the outreach that you do so spectacularly well?
Thanks. Yeah. It's a lot of fun for me to do the outreach. My view is that academia and science, it's a big field, and we have room for lots of different kinds of folks. And there's places for people to contribute in lots of ways. There are folks who are good at outreach, and there are folks who are great at teaching, and there are folks who are great at research, and there are folks who are great at building tools, and we need all of them. I don't think everybody has to do every part of it. And that's one of the strengths, is that we can really attract people to do their bits. For me, specialization is like a sign of progress. I mean, I don't raise my own, I don't farm my own food. I'm not my own doctor. I outsource those bits. So I think it's fine if some folks like to do it and other folks don't. I certainly wouldn't say that everybody needs to do outreach. Not everybody, enjoys it. For me, it is a pleasure, and I do feel this sense that we should make some parts of us accessible. The people do pay for science, and the science is, of the people, by the people, and for the people. So we do have, as an institution, not as individuals, an obligation, I think, to come and talk to people, to explain to them why we're doing it, what we're doing, and why we're doing it, why it's amazing and fun, and how they can feel a part of it. I think it's important to sort of break down this barrier where people feel like scientists are inaccessible. One of the things that I do is I hold public office hours where I hang out on Zoom for an hour, and anybody can come and ask physics questions. And it sort of grows out of, office hours at the university, where the students can come and they feel like they have access to you. They could ask you about your career, or they can ask you physics questions or whatever. And there's this sense that they can hang out with you a little bit. And so I like doing public office hours because it makes people feel like hey, there's a resource available. I can go and ask this question, or I can talk to a physicist about X, Y, or Z. And people show up, and sometimes they ask for career advice, and sometimes they ask physics questions. And I think that's a lot of fun. The other question you ask is really interesting also, is how do you balance this sort of career-wise? Because, as you say, it's not something that's always prized within academia. And I have students now who come to UCI partially because they're into outreach and they know that folks here do it. And I tell them that unfortunately it's not something that's going to get you a job. If you want to be a physics professor, having a podcast is not what's going to get you that position. There's opportunity, there's opportunities to branch out after you have tenure, but the institution is still a little weird. I like the way Sean Carroll says it. He says, "You're allowed to have hobbies as a professor as long as they're not science hobbies. Like nobody would criticize you if you liked riding horses on the weekends, but if your hobby on the weekends is doing science outreach, then they have this sense that it somehow diminishes your focus on science itself." You and I know that's silly. I actually think that working on the podcast and all these other projects fuels my love for science. It reminds me why it's fun and exciting. It taps into that basic curiosity and interest in the deep questions about the universe. It helps me broaden my knowledge as I do reading to prepare to talk about some topic on the podcast. So for me, it's been a really wonderful experience. And also, getting to work with artistic and creative people like Jorge, who ropes me into amazing projects I never, ever would have been involved in otherwise.
Yeah, speaking of Jorge.
Yeah, but basically, the answer, Brian, is that every professor should hire a cartoonist. I think that would help both professions a lot, I think.
Yeah, although it sounds like, if I recall correctly, you kind of hired him. You were writing some stuff about the Higgs, and you approached him. But yeah, just to add to that, I always joke there's no one skill called scientist. There's no one skill called cartoonist, right? There's no one skill called podcaster. It's all these micro skills, and we never develop them, even in our scientists, where we are paid so dearly in the state of California to do so. So let's turn to the book. The book is frequently asked questions, and I thought that Daniel was a Bayesian. That's an inside joke. But what is the most frequent of all frequent questions? Is it asteroid dinosaur related? Is it black hole related? Is it extra dimensions and alien related? What's the most frequent of the facts of the universe?
Yeah, well, I think the title is sort of not just data and statistically driven. It's also sort of spiritually driven. We try to tap into questions that not only we get a lot on the podcast, through the podcast or through our talks and things like that, but also just questions that, we thought humanity has been asking for a long time. Big questions like, where does the universe come from? Or why can we go to other stars and visit other stars? Or can we somehow, is there another Earth out there? Or why haven't aliens visited us? Those are the questions we cover in the book. We just try to focus on really sort of like existential questions that make you sort of think about the nature of the universe, about your role in it, or whether your very existence in it. And also we balance that with real questions we get from listeners.
Yeah,
that's right. And as we say near the end of the book, maybe the most frequently asked question is the one that comes second. Like, people ask us a question about some physics, and then they ask us, what does it mean? All right, so we have this theory about how the universe started. What does that mean about the universe, or about my life, or what does that tell me? And I think that's really fun because it connects to the bridge between physics and philosophy. That physics, the things we learn about the universe from physics, can tell us things about how to live our lives and what it means. And so for me, maybe the most frequently asked question is that implicit one. There's like, what does it mean the universe is this way and not the other way?
What does it mean, man? That said, we do. There is one question we covered in the book that we do seem to get a lot, and it's one about black holes. There's a chapter in the book about, it's sort of like a beat by beat of what happens if you fall into a black hole. What are you going to experience? Are you actually going to die? Can you survive going into the black hole? So for some reason, people seem to be really curious about black holes, and probably because we don't know what's in them.
Yeah, exactly. Right. We always get the questions about the things that are mysterious to everybody. I always like questions that start off with, this is a simple question, but what happens if you shrank the Planck scale by a factor of it? So let's talk about black holes. I love this chapter. What happens if I get sucked into a black hole? And partially because it's familiar, but it's also kind of dastardly remote. I mean, nobody knows what happens ultimately, and I think a lot of the questions are answered by that, and that's what's so exciting about science. Like, I always say, you never win science. Science is not a finite game like chess. There are finite games within it, like getting into grad school, getting a tenure track position, winning the Nobel Prize. Those are all zero-sum games or so-called finite games. But science isn't. And so, of course, there's going to be things that we don't know. And John Archibald Wheeler once said, science is like expanding this island, the size of an island. And as you do so, the ocean of ignorance gets smaller, but the boundary between them also grows. So this question I get a lot. And actually, I've asked that not necessarily to Sir Roger Penrose or Reinhard Genzel when they were on my show, but I want to ask you guys. The fact that we don't know exactly what happens has been troubling me and many people. So let me ask maybe an expert question. Because we often hear that we need a quantum theory of gravity to understand a black hole singularity, can we ever know without such a thing? In other words, is it really a two-part question that what is the ultimate, quantization of gravity, or is that even possible? And then we can ask what happens if you go inside a black hole. So either one of you guys.
I think that's a question for you, Jorge.
Yeah, that's Jorge. Please take it over.
Of course, yeah. But I'll defer to Daniel on this one, even though I think I can answer it just from having recorded 300 episodes of our podcast together.
Well, it's a really fun question because it sort of goes to the balance between experimental and theoretical physics, right? Like, can you figure this stuff out before you see it? Or do you need to see it in order to understand? And the thing that's fascinating for me about the black holes is that we sort of do know what's in them. What's in them are the secrets to quantum gravity. Like, if you could go inside a black hole and observe what's going on in there, is there a singularity? Is there some quantum fuzziness? That would tell you a lot of what you needed to know, presumably, to build a quantum theory of gravity. And so that's sort of like what we need. And the thing that's wonderful about the universe, and the reason that I'm an experimentalist and not a theorist, is that some of these things just have to be discovered. You can't just sit in a cave somewhere and think your way through the puzzle of the universe. You have to go out and explore, because the universe is constantly confronting us with things we never imagined, which take us 100 years to come to terms with. Like, is it really that way? What? Are you sure? And then finally, 100 years later, undergrads are like, oh, of course. It takes a while. And so I think you have to go out and to explore, sometimes to discover these things. Now, of course, it's possible that somebody out there has a theory of quantum gravity, or will develop one, which later we prove to be correct. But I think it's much more likely that some weird discovery we make, something which violates general relativity, maybe on the micro scale, these experiments with like small, quantumly entangled, gravitationally interacting particles, maybe will give us a sense for the direction of quantum gravity. But I think it's the experiments that need to lead the way, because I suspect the universe is weirder than even theorists can imagine.
And Jorge, I actually do find it kind of curious to know if you were inspired in any way by a great cartoonist by the name of Sir Roger Penrose, who did tremendous work. Some say he won his Nobel Prize for a single diagram in a 1964 paper on the space-time properties of black holes. He, of course, draws all sorts of whimsical shapes and so forth. And maybe that's connected to this concept of discovery that we mentioned earlier. But are there, places in physics that lend themselves more naturally to artistic depiction?
Yeah, well, it's kind of tricky because, if we sort of know what it looks like, then it's easy to draw. But then you don't get to use your imagination as much. Whereas if we don't know what it looks like, then, I'm sort of free to imagine or interpret that or come up with interesting ways to depict it. But then, it's like, who knows? Who knows if I'm right or not? I would say sort of the hardest thing I always find hard to draw is just the idea of quantum physics and things like the fuzziness of particles or the orbitals around the nucleus of an atom. Those are things that maybe a two-dimensional black and white drawing are kind of difficult to really capture. But yeah, no, I agree. Everyone who draws cartoons is a genius, for sure.
And so for both of you guys, in the zeitgeist, in the spirit of the times, this will be out after Halloween, unfortunately, but the ghost of the times, the spirit of the times, have been aliens. Not just aliens, UFOs. That is covered in Facts About the Universe. What does that kind of reveal more? Is it more of a scientific question? Is it a sociological question? Is it an escapist question? That David Kaiser, when he was on the show discussing his book, Quantum Legacies, talked about, this confluence of the nuclear age and the information age, and that led to, sightings and thoughts about extraterrestrials, et cetera, et cetera. What do you make of this lately, either one of you or both of you? And this notion that, we are being visited potentially by an extraterrestrial intelligence of some kind, and there are events that we can't explain. And I guess the question is, where does the boundary of saying, well, we have no idea, we leave off and say, well, there are some ideas that actually we have some idea, but not a great idea. So maybe Daniel first. What do you make of this? First of all, this popularity of the notion of UFOs in the public, and then maybe Jorge, what do you do with this? How do you address it in a way that's respectful but also takes it seriously?
Yeah, it's a lot of fun. And I'm always saying on the podcast, I'm looking forward to the alien invasion, because in that brief moment before they eat us or zap us, maybe they'll share with us their theory of quantum gravity, and, that'll make it all worth it. And so I read these reports with enthusiasm. I'm like, ooh, yay, maybe the aliens have come. I mean, I think people on the podcast hear me being skeptical, but I'm also optimistic. I'm open-minded. I definitely want this to happen. I want to believe. But it's hard to look at, frankly, any of these events, these Navy pilot reports or the videos, and take much away from them that's sort of concrete if you put your skeptic's hat on. We actually had Mick West on our podcast, and we went through a lot of these videos sort of frame by frame and broke them down. And a lot of them, frankly, have prosaic explanations. You can understand why this looks this way because of lens flare, or this one is, sort of a forced perspective, and none of this is conclusive, but if there are simple explanations for these things, then it's hard to come away with a conclusion that there's something going on we don't understand. Unfortunately, and a bunch of people wrote in after that episode and was like, how could you have somebody like Mick West on your program? He's anti-alien, and I don't think he's anti-alien. I think he's looking for an explanation that's reasonable and that's simple. And that's what we have to do before we conclude that something is extraterrestrial or alien. Then we have to, we have to dismiss all other possibilities. We have to assess them at least. Mm-hmm. And I think that this question about aliens really breaks into two. One is people seeing weird stuff out their windows or things you can't explain, these sort of UFO phenomena. But I think there's a much more serious and exciting understanding in the last 20 or 30 years that the universe is filled with habitable planets, and that makes the prospect that there really are extraterrestrials out there, maybe not here on Earth, but out there in the universe, much more scientifically responsible to imagine. And so I think that maybe drives it. Maybe there's a coupling between the legitimate scientific exploration of the question of extraterrestrial intelligence out there and people's excitement for things they see, the weird videos and the things they see out their windows.
Mm-hmm. Yeah, and using it as an opportunity to explain legitimate, as you say, scientific questions. And I agree. I had on Mick as well, and I actually had on people from the Jasons, the super secret society, and they're all like, "Yeah, hell, this would be great. I'd love to, learn, to win the next 80 Nobel Prizes in a row or something." But yeah, in the same token, we have to be careful and think about, well, is this really data? Who does it belong to? What are eyewitness accounts? How are they reliable? If we all had a courtroom sketch artist like Jorge around at all times, of course, everything would be documented perfectly. Another thing that, maybe ties into that is this notion of another Earth. And this had some really lovely ideas and depictions. And Jorge, was there a chapter that was the most fun for you to kind of illustrate and contribute to, or are they all like your children singular, that they're all your favorite?
Yeah, I don't have as many kids as you have, Brian, but I do love all of my drawings. They're all special in their own special way.
Yes.
No, they're all good. They're all fun to draw. I mean, that one about Another Earth was particularly fun just because we had a lot of fun kind of thinking about this question, like, is there another planet we could live in somewhere else? And what would that mean? What would they look like? And so there's a lot of fun cartoons about like a rocky planet and sort of dressed like a rock star, or, sort of thinking of another planet as like a home remodeling project and what that would take, and whether or like sort of like going home shopping and what sort of things would you want to look for when shopping for a new home for your species or your entire civilization. So that one was fun to draw.
And maybe I could just step in and sing Jorge's praises for a moment here, because, one of the reasons that this book contains cartoons is that some things are difficult to describe with words. You really need something visual. And often when I was writing first drafts of this, I would think, well, this is tricky. I'm sure Jorge can sort this out with a nice cartoon. And then it comes back to me with this amazing depiction that really like crystallizes the ideas and shows you how things connect, or, pokes fun at something at the heart of it. So I really love all the drawings that he put in there, because it's not just there for comic relief and to break up the pages. They really contribute to the essential science communication and making it understandable.
And dovetailing from there into briefly into Eleanor Wonders Why for a second, how do you come up with topics, or are they handed to you by the network bigwigs? That you have to cover, the simulation hypothesis, which we'll get to in a bit. Whatever. How do you come up with ideas for the series?
For the TV show, you mean?
Our network overlords are PBS, so they don't wear big wigs. They're very humble people and very nice. They wear medium-sized wigs.
Well, for that show, we really started from what we thought questions kids might ask. Because there's lots of things adults like to talk about science. They get excited about X, Y, Z. Yeah. But we really wanted to make sure that every episode was answering a kid's question. And, Jorge has kids, and the show is named after his daughter, who asks lots of questions. And you have kids, and I have kids, and we spend time around kids. So we know the kids come at these things with a different set of preconceptions, and they ask questions which are amazing or interesting. And so we sort of put on our 3-year-old goggles and just walked around the neighborhood or the world and looked at it and said, like, what questions would kids ask? And so every episode starts with a real question we think a kid can ask. And sometimes questions our kids asked us, or, a neighbor kid asked me one day and I was like, ooh, that's a good one. Why do spider webs have holes in them, for example? Stuff like this.
Yeah, very good.
Yeah, and sort of what we can do, Daniel and I sort of lasted us for about 40 episodes, but we still needed 40 more. And so we were thankful to have just a great team of writers. These shows have like a writing staff, a writing team, and we try to tap people who were not normal writers and people who were lifetime children's writers, and everyone came in with just really great and fun ideas about. Just again, like what does the world look like to little kids, and how can we kind of inspire them to explore?
Another topic that's kind of again in the public mind is the so-called simulation hypothesis. I love that chapter in the book. Are we living in a simulation? It's some of these are just not falsifiable. So how do you approach a subject like that? Maybe Daniel first, what is the simulation hypothesis for those that might not be familiar? And then, Jorge, how could you even depict such a thing in the way that you did, or what inspired you to provide this kind of really fleshing out as we would say, the complete vector space of all these different possibilities of something that's admittedly both extremely complex to even describe, but also to be verified, or to approach using the finite tools of the scientific method. So Daniel, what is a simulation hypothesis, and then Jorge, how did you choose to approach it?
Simulation hypothesis is something people are probably familiar with by now. It's this idea that perhaps our lives are not real, the universe is not physical, that we live inside a simulation in a computer in some other sort of like super meta universe. And it's not unusual or weird to think about writing a simulation in a computer. We do it all the time in science. We say, what would happen if these two galaxies collided? And we write a little computer program that simulates it to give us the answer. And so you might imagine that if you had a simulation that was complex enough that it could have life emerge inside of it, an intelligent life, that those beings that lived inside that simulation in your computer might not be aware of the fact that they're inside a simulation. How would they know? And so that, you flip that around and you say, well, maybe our universe is a simulation from some very incredible high-performance computer in some other universe. And you're right that it's not necessarily something we can verify, though. In the book, we talk about, ways you might be able to figure out you're in a simulation, looking for bugs or computational limitations, etc. But science isn't limited to things we can necessarily falsify. There's lots of theories of science and how it can proceed. A lot of folks focus on things that are experimentally falsifiable, but it's also possible to make arguments like, if you could come up with a theory of the universe that was the only one that's consistent with our data, and it has implications for things that you cannot measure, then you could conclude that those things are probably real. So I don't think that you necessarily need to be able to experimentally interact with things in order to have a strong argument that they're real. Though, of course, as an experimentalist, I always want to have the hard truth, the data. I want to go see it or touch it or send a probe out there. So it'd be pretty cool to get to interact with the masters of the universe if we do live in a simulation.
And of course, I think today Mark Zuckerberg announced the metaverse or something like that. Jorge, how do you approach, depicting things that, may or may not be legitimate to demand that they're falsifiable or not, but yet that's a common refrain. All the more so when it could be you who's being simulated, drawing the simulation, and so we could get really meta on this and ask, who's simulating the simulators? Is that the Coast Guard's job? Yeah, who does that? But anyway, Jorge, how do you depict something for which we have zero evidence, at least at present?
Yeah. Maybe we're all NPCs, non-physics characters. Really.
Nice.
No, yeah, this was my favorite kind of question to tackle in the book, just because it is so wild and so potentially unfalsifiable and so kind of out there to draw. And, I think our general approach was to tackle these kinds of questions in a way that not just kind of gets to an answer, but also kind of demonstrate a little bit how physics and scientists and engineers would sort of tackle these big questions. We asked the question also in the book, is an afterlife possible? And usually that's, sort of a ticking time bomb in science and religion and things like that. But, we try to show kind of like, well, how would a scientist approach this? Like, let's break it down. Like, well, what exactly do you mean by simulation, and what would that mean, and what are some of the different ways that could happen, and what would be some of the implications for that, what are some of the ways in which you could maybe potentially demonstrate whether or not that's true or not, and so I had a lot of fun drawing little brains and vats. I think that's the go-to. A little brain hooked up to a PlayStation 4 is sort of the go-to depiction of the simulated world.
And then there are, in contradistinction to those, or contrast to those, there are chapters in this delightful book, frequently asked questions about the universe. Of course, it could have been the multiverse. You talk about other universes. So I think you show a pro-universe bias that I find. Not only but Andre Linde has made a claim that you should not be prejudiced to think of it as a universe. First, you should think of it as a multiverse. So anyway, next book idea title.
Actually, that was a dinner time question my daughter Eleanor asked me one day out of the blue. I mean, I think she was like 6 or 7, and she's like, how can there be multiple universes? Wouldn't they all just be the universe?
Yeah.
And I was like, you got all physics.
That's right.
there.
When we were kids,
Like,
that's all there was.
that
Right?
naming conventions. That's the problem.
But that actually brings up something interesting that, when I was reading this book, like the caliber of the question, some of them are for kid level, there's one, when will the sun burn out? Okay. That has a very, specific scientific rationale that we can approach and answer definitively. Unlike, well, we have no idea, see our first book, buy our first book. No, you guys don't do that, as I would shamelessly do. But some of the questions that are asked, at least by and Eleanor and other work that you guys do, it is a lot higher than what we would have asked, right? And as kids, just like 30 years ago, 40 years ago, we're all approximately, to a physicist, the same age. I'm probably the oldest one, but anyway, looking back at when I was a kid, I wouldn't ask, what about the multiverse or the simulation hypothesis? And now our kids are asking such questions, and the appropriate response is, go to bed or do your homework. But do you think
because Einstein said so?
Do you think that science is inevitably going to lead to smarter and smarter children? If the Matrix isn't caused by a future advanced civilization, it could be a civilization that's currently living among us, namely our kids. So the caliber of questions of our kids are really getting much more sophisticated, wouldn't you say?
Absolutely. And I think that's progress. I think things that were cutting edge, controversial ideas 100 years ago, now we can teach them to 5-year-olds.
Yeah.
And I think that's wonderful. I know that, for example, if I was able to get into a time machine and go to the year 3000, I wouldn't go to a physics conference because there's no way I'd figure it out. I'd go to the children's section of the library and I'd start reading astronomy books and cosmology books for 5-year-olds, because that'd be the only thing I'd ever have a chance to even understand. And so I think that just shows the sort of slow rolling nature of scientific progress. The basic ideas, our basic view of the universe has changed. And so now what we teach to children, and therefore the questions they ask, are also changing. I think that's pretty awesome.
Mm-hmm. And so the last topic before we turn, I want to spend some time talking about your podcast and getting some ideas that I can poach to grow my podcast from you guys. But is this notion of why? I was always taught that why is not a scientific question. Why is there this? It's some teleological method, motivation of intent, which you can't ascribe to the blind, pitiless indifference of the universe's inexorable evolution. What do you guys say? The last chapter talks about why, is a why question. I don't like to give away the book, and I want people to buy every single version of this book possible. So are why questions, are they not taboo, guys? And why do you end with a why, if I can ask a double why?
Yeah. Well, we're all, our kids just call Eleanor wonders why. And so if that's not allowed, then we're in trouble. But yeah, I know that there's been a sort of a traditional line between philosophy and physics, but I never saw a why question as being particularly taboo. You can ask why is the sky blue, and that definitely has an answer. You can definitely give a physical answer to that, right?
Mm-hmm. Sure, yeah, and sometimes we confuse why with how or what. I do remember a saying of Einstein where he attributed his curiosity later on in life to the fact that he never asked certain questions as a kid. In fact, he credited the sophistication with which he approached questions as a 25-year-old patent clerk to the fact that he never asked these questions. He made explicit mention that I never asked my dad what happened if I traveled alongside a light beam and looked at myself in the mirror, or tried to send a TikTok, But he said, because if I did, my dad would have given me the best answer of the time, which was wrong because he had to wait until he himself came about. So I think that as much as we do want to, kind of inculcate this notion of curiosity amongst kids, et cetera, we also have to, recognize that sometimes the sophistication of the answer can't be really appreciated until one is much, much more developed. And it's not a knock. It's just, it's like you can't paint a masterpiece, straight out of kindergarten. So finding that balance, I think, is sort of crucial. And maybe this dovetails a little bit into the podcast, because you kind of blend a melange of styles. And sometimes you have guests, sometimes two, you guys are riffing. And how do you approach it? How do you approach different topics? Is it just, what people, send in, or is it stuff that you're really curious about, or guests like Mick West you talked about, or, your most, impressive guest to date, yours truly. But tell me, what is your strategy there? Is it one of like, I'm interested in this, let's find it out? Or is it like, how do you balance appealing to what the audience wants versus what you guys want?
Yeah, great question. First, let me chime in on the previous one about physics and philosophy. Yeah. I think that you're right that often physics tries to stay separate from philosophy, that a lot of physicists eschew, talking about philosophy. I think that's silly. I think that there's not a crisp and clear line between the two. I think that a lot of the questions we ask in physics have philosophical motivations, and the answers we get from physics have philosophical consequences. And even the people who say, like, philosophy is a waste of time, they don't realize that's a philosophical position. They're, in effect, doing philosophy without even, really thinking about it carefully. So I would say that why questions are vital, that why questions fuel the how questions, and how answers inform the why questions. So I think it's all a wonderful mixture. Here at UCI, we have a lot of folks who do really interesting philosophy of science, and I'm often over at their seminars asking naive physicist questions. But to your point about the podcast, I think that we do all of that. We sometimes do questions where I think this is something will blow people's minds and is not widely appreciated, or I haven't seen talked about in an accessible way before, that I think people will find really, really cool. For example, we recently had an episode on the WIMP miracle, and a lot of people are interested in dark matter, but there's not a lot of accessible discussion out there for why science coalesced around this idea of dark matter as a particle. And in large part, it was because of this WIMP miracle, this suggestion that maybe dark matter was this weakly interacting massive particle. And so we talk about that, and a lot of topics come from listeners. They write to us and they ask us, hey, can you explain this? Or they say, I need a Daniel and Jorge treatment of this. They send me an article. They're like, I didn't get it. What's going on? Can you break this down? And so we have a big mixture of stuff, whatever people find fun. And we explore different topics. Sometimes we interview science fiction authors about the universes they build in their books and the physics of it, which I think is a lot of fun also.
And Daniel, you also take questions from listeners, right? If people send in questions, and sometimes we not just devote episodes to answering questions, but also they inspire topics to cover, right?
Yeah,
absolutely. Yeah. People can write to us with any question to questions@danielandjorge.com. We actually answer every single email, usually within a day or so. And some of the really good questions, we talk about them on the podcast. A whole episode can be devoted to that. Or sometimes people send in an audio of themselves asking questions, and we have a whole episode just answering listener questions, which is really fun. And I'm, try really hard to engage with the audience and make them feel like they're a part of this process. It's like a conversation, not just a one-directional podcast from us to them.
And maybe, Daniel, to wrap up, I want to get your impression of, there's been a lot of recent particle physics results, and you are, of course, one of the preeminent experimental particle physicists in the world, and doing yeoman's work, from everything from working on LHC work to your crayfish IO, which I'd love to hear about again in person next time you come and give a colloquium here. Been a lot of results. G-2. There's been the LHCb results, actually a couple of them. Just yesterday, we're recording this on the 28th of October, and just yesterday there were results from Microboon claiming, on one hand, consistency with the standard model, on the other hand, a whole new chapter of physics has been opened up, and what's going on here? Are there really fifth forces and physics beyond the standard model, or is that just what big particle physics has to do in order to get its bread buttered? Be honest.
All right.
Are we seeing a fight here? Am I seeing the beginning of a fight here between a
Yeah, because cosmologists never hype our results.
yeah cosmology versus particle physics? Let me get some popcorn. Hold on.
Yeah. No, you're about to see a fight, but it's between two personalities I have inside my own head. There's the optimist and there's the pessimist, or the cynic. The optimist says, we know there's physics beyond the standard model. There's dark matter, there's neutrinos, there's all sorts of stuff that we just cannot describe with the standard model. We know it's not everything. On the other hand, the cynic says, I don't really think that anything we've seen is very exciting or persuasive. I really am kind of a cynic when it comes to these discoveries because they tend to come and go and people get really excited about them and then they fade away often. And so, let's talk about the individual ones. You talked about the LHCb measurement, and this is a measurement of, whether particles talk to electrons and muons at the same level. Muons are like the heavy cousins of electrons, and we think it's important in our theory that these particles interact with electrons and muons and also taus at the same level, and LHCb sees this evidence that maybe they don't. But if you add up all the numbers, they see some hints, but it's not really very conclusive. It's a tantalizing hint because we want to find something and we look in lots and lots of places. So if you do that, then eventually you're going to find something weird. It's like if you set 1,000 monkeys to flip a coin 100 times, some of them are going to give you weird results, pretty far from the distribution 50-50. And so that's sort of the situation. We're desperate to find something new and we're hunting for tantalizing new effects. The muon G-2 is also interesting because, what they saw there doesn't agree with the theoretical prediction. But the theoretical prediction also doesn't agree with other theoretical predictions. And so it's hard to really be terribly excited about that. And the microboon one is sort of the most head-scratching. But my version of the story is maybe the least exciting. That came out of an experiment called LSND decades ago that had a result that nobody understood. And frankly, a lot of people were skeptical of. They thought maybe they didn't understand something. And then they did a follow-up experiment to try to understand it called Mini-Boon. And Mini-Boon saw something else weird that they didn't understand that wasn't consistent with LSND. And I remember thinking at the time, well, it's the same folks. Maybe, they don't understand the backgrounds they expect in that experiment. And now Microboon has come out and basically said no to the favorite theory that could describe LSND and Mini-Boon. And to me, that just says, well, the most likely explanation is that those experimentalists, got it wrong. They didn't understand their backgrounds as well as they thought they did. Not that there's some new chapter of physics. So I'm really kind of a cynic when it comes to, declaring that one of these discoveries is really heralding some new physics. I really got to see a lot more data before I get excited about it.
I think that harkens back maybe even to your first book, We Have No Idea. Sometimes you get, spend millions of dollars and decades of your life, and you get what's called a null result. And you get something that's just not, inconsistent with what came before. And those are important. They don't usually happen to make the front page of the OC Register, the Pasadena Star News. These are all, like a rock concert. Now, he said my city's name now, or the San Diego Union Tribune. I can't neglect the paper of record. But this is. It's always interesting to have this rubric, and I think you guys do it so well. What we can understand, what we can't, what we can potentially not understand, and everything in between, and giving people permission to ask these questions and to have legitimate, serious answers. And I think that is very commendable. And I want to give maybe just the last word to Jorge. What is going on with PhD comics? Sometimes I see it's like regular, it's coming out. Sometimes, there's a new comic. I retweeted one. I was like, this is like ripped from today's headlines, and it's from 2010. What's going on with PhD comics?
Yeah, a great question. I don't know. Is quite the answer. I did it for like 20, 15 years, and then all these amazing other fun projects came in, making movies based on the comics, starting a YouTube animation collaborative, and then the book with Daniel, and the podcast and the TV show. And so, thank you to all my fans for being patient. But these days I sort of just kind of when I find the time is sort of, or when I feel inspired, and is when I'll post a new one. Or, so even like posting old comics is sort of a lot of work, and so sometimes I get inspired and really want to connect with people, and so I'll start posting again. But yeah, there's just too much fun work to do.
That's right. Too short the life, as your encomium blurb writer Carlo Rovelli always says. The life is just too short. But you guys are making a huge dent in the multiverse with this latest contribution to the scientific oeuvre. Frequently asked questions about the universe. Jorge Cham, Daniel Whiteson. So my original two guests. Actually, last time you were together, and I had to like virtually pull you apart. You guys were just that. No, but it's you guys have such a great chemistry. It's always a delight when a book comes out, but it's a delight when every one of your podcast episodes, and Eleanor asks why, wonders why. You guys keep doing what you're doing. It's so vital. It's so commendable. And I just want to congratulate you guys. You guys are the real deal. You set the standard for other podcasters and science communicators to aspire to. So I want to thank you guys so much and wish you the greatest of success with this wonderful book, and promise me you'll come back on the podcast again and again, if only to just discuss the latest weather, because it's always a fascinating time to be with you guys.
Yeah, why is it hot? Or is that not a question we're supposed to ask?
Southern California, it's not atypical. Thank you guys, and best of luck with this wonderful new book.
Yeah, thank you, Brian. All those things, same to you.
Any sufficiently advanced technology is indistinguishable from magic.